This lesson is on expanding expressions. And in this, what we need to be aware of, the first thing is that in algebra, you need to know what like terms are. Like terms have the same pronumeral. An example of like terms having the same pronumeral would be if I had, say, an expression of, say, 7x plus 5x minus 3y plus 8y. Well, the like terms are the ones that have the same pronumerals, so the 7x and the 5x, they're like terms. And the minus 3y and the plus 8y are also like terms. Okay, and a second important thing that has a formal definition called the distributive law, which you would probably just know as expanding brackets. So an algebraic expression or example of the distributive law would look maybe something like this. If I had A outside of B plus C, then what we do is that A is going to multiply each term that is inside the brackets. And as a result, A times B would give AB, and then there's the plus sign, and then A times C would give AC. That's one example. We can also have something that uses the distributive law called a binomial product. And the binomial product is really just another application of the distributive law. A general example would be A plus B times C plus D. And now again, what we have to have is that all these terms are going to multiply one another, so every term in the first set of brackets has to multiply each term in the second set of brackets. So the A is going to multiply the C, and the A is going to multiply the D. That's the first term multiplying each term in the second set of brackets. Then the B multiplies the C, and the B multiplies the D. So the second term in the first bracket multiplies each term in the second set of brackets. And the answer we get will be, we've got A times C, so we'll have AC. A times D, we'll have AD. B times C, we'll have BC. And B times D, we'll have BD. Right, that's the binomial product. Now, there are two really important applications of the binomial product, and they're called perfect squares and also the difference of two squares. All right, so with perfect squares, what we end up having is, for example, could have A plus B all squared. That will give us a perfect square. That's really the same as saying A plus B times A plus B. That is A plus B all squared. It's a perfect square. And now if we do the distributive law, or apply the distributive law to this perfect square, each of the terms in the first bracket multiplies each of the terms in the second bracket, and we'll end up with A squared plus AB plus BA plus B squared, and that will give us, when we simplify, A squared plus 2AB plus B squared. Alright, that's the first example of a perfect square. Another perfect square that we have is A minus B all squared. We'll call this the first one, and this is the second one. And if we do that, again, we'll have A minus B times A minus B, which gives us, when we do the distributive law, when we apply the distributive law to this, we'll end up with A squared minus AB minus BA plus B squared. And so if we bring all of that and simplify it, bring it all together and simplify that, we'll have A squared minus 2AB plus B squared. Perfect squares. These two things, perfect squares, are going to crop up over and over again in your mathematics over the coming years. It is so important to remember those two perfect squares and what the outcome is, so that you can go straight from what's in the brackets down to the final line here, and you can do the reverse. You can go from the final line and go straight back up to what's in the brackets. Doing that will save you a whole heap of time in problems and during exams and assignments and homework, and that will give you more time to work on other things. The last thing we need to look at is a difference of two squares. Okay, with a difference of two squares, a general example would be something like this, where we've got two sets of brackets, and in the first set of brackets we would have a plus b, and in the second set of brackets we would have a minus b. If we apply the distributive law again to these brackets and to these terms, what we find is that we'll get a squared minus ab plus ba minus b squared. And looking carefully at these two terms here, the minus ab and the plus ba, they're actually going to cancel one another out. So all we're left with in the end is a squared minus b squared. Okay, again, it is really important to know that we get from this expression here, and that's what it looks like when we've multiplied those terms all through, applying the distributive law. And it's also important to know that if you can recognize an expression like this, that it will immediately factorize to look like something that we've got on our first line there. Difference of two squares and perfect squares, very important concepts to understand when expanding brackets. In the next little video, what I'm going to do is actually do some worked examples from the textbook and hopefully show you how to apply these different concepts.